Today, we'll be explaining the parts and operations of a sextant. This is a maritime sextant, and there are many individual parts on it. Let us take a closer look. This is the arc. While these filters at the front are used to filter out sunlight or bright lights. This is the horizon mirror, while this is the index mirror. The arc is used in conjunction with the index bar to find the altitude of a celestial body. On the other hand, this is the scope. To attach the scope, you will need to loosen the screw here. Slot the scope into the sextant. And then tighten the screw. Ensure the scope is securely fastened. And this is what looking through the scope should look like. For nighttime usage, some sextants come with a light to help with the reading of the arc. By pinching the index bar, it is possible to rotate it around the arc. Ensure that it is 0 degrees before usage and add some filters to protect your lights from any excessive light. Look through the scope and acquire the celestial body of choice. And by rotating the arc downwards and the index bar forward, you can bring the celestial body to the surface. During the entire process, ensure that the celestial body stays at the center of the scope. For fine-tuned adjustments of the index bar, a micrometer drum is used. And this is how it should look like in practice. Be careful not to accidentally bring the index bar past the 0 degree mark. Always ensure the maximum amount of filter is used, before gradually removing one by one to ensure not to damage your eyes. Now, let us take a look at the correctable errors. There are 3 kinds of errors: perpendicularity error, side error, as well as index error. Perpendicularity error is when the index mirror is not perpendicular to the plane of the instrument. To check for perpendicularity error, set the arc to around 30 to 40 degrees, and check from the top of the sextant if the arc appears to be continuous on the index mirror. If it doesn't, perpendicularity error is present. To correct it, adjust the screw on the top of the index mirror until the arc appears to be continuous. Side error is when the horizon mirror is not perpendicular to the plane. Index mirror error is when the index and horizon mirror are not parallel to each other when the instrument is set at 0 degrees. Index error is present when horizon does not form a line. To correct, set the arc to 0. Tilt your head up to the side about 40 to 90 degrees and side error will show. Correct the screw furthest from the frame until horizon forms a continuous line. Bring your head back, and now if the horizon is still not aligned, it is due to index error. Correct it by adjusting the screw closest to you until the horizon forms a line. Repeat both processes until you eliminate both errors. If unable to do so, eliminate all side errors and remaining index error will have to be eliminated via calculations. Errors on the arc will be subtracted, while errors off the arc will be added. There, we will have the true altitude.
So, on the chart, you would have your date reckon position, and from the date reckon position you'll draw your azimuth line towards the GP of the celestial body. After that, for the position circle, when you draw it, you will have to look at your intercept, either towards or away. The towards or away of the intercept will affect which side the position circle will be. The intercept value itself will be the distance between your date reckon and your position circle. So in this case, in front of the date reckon will be towards and behind it will be away. So to get your true zenith distance, it is as we learnt in class. You first take your sextant altitude and then you factor in the index error on or off. After that, you will get your observer altitude, which you then will look through the almanac and find the dip, which depends on the height, your observer height. From that, you'll be able to find the approximate altitude, which you will then have to correct as well with your true corrections, which you will also find in the almanac at the front. From that, you can find your true altitude, and then from that, you will be able to find your true zenith distance.